Starting in Flutter, one thing you probably hear a lot is state management. Yes, we know that effective state management is very essential to building robust applications, but what is state management? State management in Flutter is all about handling and updating data efficiently. Let's take a closer look. First off, in Flutter, state refers to any data that can change over time and affect the way your app looks or behaves. This could be user input, network data, or even things like device orientation. Next, we understand that when dealing with UI, Flutter uses widgets. It can either be stateless widgets, which just display what's given to them without any change, or stateful widgets, which are more dynamic because they hold state data and can rebuild themselves whenever the data changes. But what if you need to share data between multiple widgets or even across different screens? That's where state management solutions come in. They provide ways to manage this shared state in a central location and notify all interested widgets whenever it changes. This keeps your UI in sync with the latest data. There are quite several approaches to state management in Flutter, each with its advantages and complexity. Today, we'll be exploring the business logic component, popularly known as Bloc, and how we use it to build applications. So quickly, before we start coding, how does Bloc work? Think of Bloc as a central communication hub that acts as a mediator between your UI widgets and your app's data layer. It all starts with a simple interaction with your UI on your device, which sends an event stream, usually with some data, to the Bloc. The Bloc receives the event, processes it based on your defined business logic, and determines the appropriate state update. Finally, the Bloc emits the new state by sending back a state stream also containing some data to the UI, which then changes to reflect the new state. By using Bloc, you achieve a clean separation of concerns, which means that your app is neatly organized and different parts of your app like UI and business logic are kept separately. In other words, widgets focus on presentation while Bloc handles the business logic and state updates. This leads to a more maintainable and organized code base. So, without further ado, let's delve deeper into how Bloc functions. We'll be building a simple expense tracker application in Flutter using the Bloc library. After creating a new Flutter project, we can make changes to the popspec.yaml file to add 1. The Bloc package, 2. The Flutter BLoC package, 3. The UUID package to easily create unique IDs for our expense objects, 4. Equatable package to help easily compare Dart objects for equality, 5. RxDart package to help with reactive streams, 6. Shared preferences package for local storage, 7. INTL package for easy formatting of our currency values, and Figma Squircle package for some nice border radius styling.
Do you have a great app idea and need help with the next steps to take? HeyFlutter is here to help. At HeyFlutter.com, we specialize in transforming ideas into impactful digital solutions. We also offer free consultations to help you understand the development process and give you a roadmap from concept to launch. Our well-experienced team of experts are ready to collaborate with you through every step to deliver your product successfully and in no time. Are you ready to bring that vision to life? Book a consultation session today. Go to heyflutter.com/consultation, fill in your details, and let's launch that awesome idea.
For this tutorial, we'll be using a simple project structure that will separate our business logic from our UI. Here are some of the main folders we'll be working with. First, the Blocs folder containing all the blocks we'll need in the app. Next, the data folder containing the data layer of our application. Next, the models folder containing the different entities or objects in our code. Then we have the pages folder containing the different pages in our application. Then we have the repositories folder containing the repositories for our app. And finally, the widgets folder containing all the custom standalone widgets we'll create. Now, let's start by creating a simple expense model. The expense model extends the equatable class, and inside it, we have the ID property of the expense, which is a string type. We have the title of the expense, which is also a string type. Then we have the amount for the expense of type double. Then the date property, which the expense was made, which is of type date time. And lastly, the property category, which is an enum of type category. You may ask, why are we using equatable? We use this so we can easily compare if two expense models are the same. This will help make sure that any expense we may have already created will not be created the second time. After that, we then add the different properties to the prop list for our equality as shown here. Next, we create our from JSON and to JSON methods for easy serialization and deserialization of data respectively. Lastly, we add our copy with method with easy copying of the expense object. After that, we can create our category enum containing the following elements. Since we are manually creating our from JSON and to JSON methods, we will do the same in the category enum as we have done here. Finally, we add some extensions to help with returning the name of the category.
In this tutorial,
we'll be using the shared preferences package to store expenses locally. Therefore, for the data layer, we'll only have the local data storage file we have created under the data folder. In the file, we create the local data storage class, and inside it, we define a private variable for the shared preferences class to make sure it is only accessed within the local data storage class. Next, we create a constructor that takes in a shared preferences object as an argument, which we can then set as our private preferences variable once initialized. After that, we will then define a behavior subject variable using the rx.dat package. It will hold our list of expenses and notify anyone when things get added or removed, keeping our data in sync. Also, make sure to seed it with an empty list. Why are we using behavior subject, you may ask? We are using this because for this tutorial, we will be using streams instead of futures. Streams allow for real-time data updates and individual expense actions like create, read, update, delete, instead of requiring the entire expense list for each operation as used in futures. We start with the save expense method, which takes in an expense object as an argument. Inside the method, we first create a copy of the list of expenses from the controller using the spread operator. We do this so we do not modify the original data held by the behavior subject. Next, we add the new expense object to the end of the expense list we just created. After that, we then add the modified expenses list to the controller so we can notify the app that the expense list has changed. Finally, we save the updated expense list to the shared preferences local storage using the expense collection key, which we have created here, and the encoded expense list data. The next thing we need to do, or we want to do, is to retrieve all the saved expenses. For this, we create a stream of the list of expenses called getExpenses, which then returns the asBroadcastString method called from the behavior subject class, which we created earlier for our list of expenses. After this, we will then create a way to retrieve the available expenses when the application is initialized. Therefore, we create a private method called _initialize. Inside it, we first retrieve the stored data from the shared preferences local storage using the getString method, and then we pass in the expense collection key. If the data is not null, we then create a new expense list from the decoded data, after which we create a mapped list from this expense list, in which we map the respective expense objects using the from JSON method. Then we can finally add the list to the behavior subject to notify the stream. And if the data is null, we simply add an empty list to the behavior subject stream. Finally, we can then call the _initialize method once the local data storage class is initialized. After creating a new expense, we may want to make some changes at some point. For the update operation, we can simply modify the save expense method to effectively save the updated expense. First, right under the new expense list we created inside the save expense method, we will get an expense index using the index where method. This will find the index of an expense whose ID matches the ID of the new expense. We do this to check if the new expense from the argument already exists in our list. Next, if the expense index is greater than or equal to 0, which means if the expense exists in the list, we can then update the expense located at the expense index in the list with the new expense from our argument. Else, we can just add the new expense object to the end of the expense list like we did before, and we leave everything else the same. Finally, for the CRUD operations, we can have the delete expense method, which takes in an ID string as an argument. Inside it, we first create a copy of the list of the expenses from the controller. Next, we get the expense index from the expense in the list that has the same ID as our argument. Then, if the expense index is equal to -1, meaning it does not exist, we can throw an exception stating that no expense was found. Otherwise, we remove this particular expense from the list using the remove at method. Then, we update the expense stream by adding the updated expenses list to the behavior subject. Finally, we save the list to the shared preferences local storage. Now, onto the repository layer. In the repositories folder, we create an expense repository class. Inside it, we define the local data storage class privately and add it to the constructor. Next, starting with the create expense method, which takes in an expense object and calls the save expense method from the local data storage class. This method will be used for both creating a new expense and updating an already existing expense. Next, we add the delete expense method, which takes in a string ID and passes it down to the delete expense method called from the local data storage class. Finally, we add the get all expenses method, which returns the stream of list of expenses from the local data storage. Once we are done creating the data and repository layers, we can then initialize them in the main method located in our main.dat file. We first change the main method to a future. Inside it, we first ensure that the widget's Flutter binding has been initialized. Then, we create an instance of the local data storage class, to which we then provide the shared preferences instance from the get instance method. Then, we also create an instance for the expense repository class and supply the storage inside. Finally, we call the run app method, and inside the app widget, we supply our created expense repository. For the app widget, we have a simple stateless widget that takes in a required property of expense repository. Inside the build method, we wrap the material app widget with a repository provider.value widget, which is gotten from the Flutter_BLoC package. Next, we supply the expense repository as the value. This will provide the expense repository to all its descendant widgets, like the widget for the list of expenses, the add expense form widget, and some others, which we will see shortly and later on in the video. Now, for creating and updating an expense, we will need a dedicated block. Therefore, inside the blocks folder, we can create a block folder using this block extension for VS Code, as shown here. The link will be provided in the description. Then, we provide the name for the block as expense_form. Don't forget to rename the folder to expense_form. Let's begin with the expense form state class, which keeps track of the information needed when creating or updating an expense. Start by creating an expense form status enum for holding the initial, loading, success, or failure status of the form. Next, we define the different fields for our expense object, including the expense form status. Then, we add the constructor for the properties with the category and status fields initialized. Next, we add a copy with method as shown here. Then, we can add all the properties to the props list for the equatable extension. Finally, we create a simple isFormValid bool to check if the important fields are not null. The next thing we do is to add the events for our expense from block. The different events that the block will react to are: number one, the expense title changed, which will take in a string for the title input. Number two, the expense amount changed, which will take in a double for the amount input. Number three, the expense date changed, which will take in a date time for the date input. Number four, expense category changed, which will take in a category for the category category input, and finally the expense submitted, which will be called when the submit button is pressed. After that, in the expense form block class, we first add the expense repository class and add it to the constructor. Next, we will need to implement the mapping of our events to the state. Don't forget to set the initial state of the block, for which we have set it as expense form state. In a block, events come in as the users interact with the UI, while states go out from the block as the UI changes. We can use the on method to set the listeners for the events. Therefore, we have set this particular listener to the expense title changed event, and inside it, we add the underscore on title changed method. For the onTitleChanged method, it will take in two arguments, the expense title changed event and a state emitter expense form state for the expense form state. Inside the method, we can then add the logic for how we want to handle the data gotten from a user when it types in a title. Therefore, we'll simply emit a new state with an updated title from the event using the copyWith method. We can do the same for the amount field. We first add the listener and supply the underscore on amount change method. Then after creating the on amount change method and adding the needed arguments, we can then first pass the input from the event, which comes in as a string. Then we emit the state with the passed value of the amount to the state. After doing this, we can do the same thing for the onDateChanged and the onCategoryChanged methods. Finally, for the onSubmitted event, inside it, we first create a new expense to which we have added a new ID using the UUID package, the title, amount, date, and category. We emit the loading state using the expense form status.loading status. We add a try catch block. Inside the try block, we asynchronously call the create expense method from the expense repository and supply the new expense to it. Then we can emit the success state using the expense form status.success state and also return the state to its initial state. Finally, in the catch block, we can emit a failed state using the expense form status.failure. Now we have created a simple add expense sheet widget which gets called up when we tap on the floating action button here. It has a title field, an amount field, a date field, a category choice list, and an add button to submit the form. We have also separated these different fields into their separate widgets so that when a field is rebuilt, it does not affect the whole add expense sheet widget. Now, starting with the title field widget, all we have to do is to listen for the state changes in the build method of this widget. And we'll do that by using the context.watch expense form block.state. The next thing to do is to use the block expense title change event we created earlier. To do this, we use the context.read expense form block.add, and then we supply the expense title change event, which we can then supply the value from the unchanged callback like this. Finally, we submit the form, but we wouldn't want to allow any inputs in the form to be added when we have already tapped the add or submit button. So we can simply make sure that the expense form status is not equal to expense form status.loading using the enabled property in the input decoration. We can also do the same thing for the amount field widget as we have done with the title field widget as shown here. For the date field widget, we are currently formatting the selected date using the intl package date format class. So inside the format method, we can then add the selected date using the state.date. And to handle the changing of the date, we then go to the show date picker method where we can first make sure that the selected date from the picker is not null. If not null, we can then add the selected date from the date picker to the expense date changed event. Next, for the category choice widget, we also add the listener for the expense form block in the build method of the widget. Using the state, we can then set the selected flag in the choice chip to compare between the current value and the value from the state.category. And finally, we can then change the unselected callback to add the expense category changed event and the currently selected value to it. Finally, for the add button widget, we first listen to the state changes from the context.watch method in the build method. We then also create the isLoading value by checking to see if the state.status is equal to expenseFormStatus.loading. Next, in the onPressed callback for the button, we can add the constant expense submitted event from the expense form block using the context.read method. And after that, we can close the bottom sheet. But we wouldn't want the user to create a form when the required fields like the title and amount are null, right? And we would also want to show some loading states on the button so we can have a better user experience, right? To do this, we first check to see if the current state of the expense form block is loading or if the required fields are null. If any of these criteria are true, we set the onPressed callback to null. If any of these criteria are not null, we can then call the submit event as seen here. For the loading state, we simply update the child property of the field button widget. If the state is loading, we show a simple loading widget we have created. Else, we show the add expense text widget. Before we use any block in a widget tree, we must first add a block provider to the top of the widget tree, where we can add any dependencies for that block. In our case, the expense repository class is a dependency on which the expense form block depends. Let's look at the widget tree for the bottom sheet. From the widget tree, we can see that we can either add the block provider just above the home page or right above the add expense widget. But since the expense form block does not get used anywhere else in the code apart from the add expense sheet widget, then we would have no need to put it so high in the widget tree. So we simply go to where the show mother bottom sheet method is called. For this, we have refactored it to a simple extension in which we created a feature called show add expense sheet. Inside the builder callback, we can then return a block provider. We add the create callback to which we can then return the expense form block. Then for the required repository property, we use the read method from the Flutter_BLoC package to supply the expense repository. With that, when we restart the app, we can tap the floating action button to show the add expense sheet. Inside it, we can then add all the required fields. We can see that if two main fields, like the title and amount fields, are not supplied, the form will not be valid and the add expense button will be disabled. But once they are filled, the button becomes enabled. And when we tap on it, the bottom sheet closes and returns to the home page. Currently, we cannot see the list of expenses we have created or anyone that has been saved locally in the storage. This is because we need to implement the block for the expense list. Therefore, let's create the expense list block using the VS Code extension for Flutter BLoC. Inside the expense list state, we create an expense list status enum. Next, we define the different fields for the expense list stage, which include a list of expenses, expense list status, total expenses, which is a double, category, which we will call filter and use it to filter our expenses by their categories. Then we create the constructor, making sure to initialize each property with their default values like this. After that, we create the copy with method for the state. But this time, for each argument, we will be using a function that returns the type for the field. Therefore, for the expense list in the state, we will use the list expense with the function expenses. For the status, we'll use the expense list status with the function for status. For the total expenses field, we'll do the same, but as double function total expenses. And finally, for the filter field, we'll use the category function and with the name filter. Inside the class, we can then set each property like this using the function arguments we just added. I have added a factory for the initial state, as we can see here. Also, add the properties to the props list for the equatable class extension. We can move on to the expense list event, which will contain three main events for this block. The first one being the expense list subscription requested, which will be triggered to subscribe to the stream of expense lists from the repository. The next one will be the expense list expense deleted, which we will use to delete a single expense from the list. For this, we'll add a property expense with its constructor and props list. Lastly, the expense list category filter changed, which we'll use to filter our expenses. For this, we'll then add a category property also with its constructor and props list. For the expense list block, we start by adding the required dependency, which is the expense repository, and we set our initial state. Next, we add the listeners for the different events with their different callbacks, which we will be creating shortly. Starting with the underscore on subscription requested callback, which maps to the expense list subscription requested event. Inside it, we can first emit a loading state, and since we are using functions for the copy with arguments to this state, we will have to set them like this. Next, we get the stream from the repository using the get all expenses stream we created earlier. After that, we call the for each method from the block emit. We first supply the stream. Next, we then update the state with the successful status and the expenses list we get from the onData callback. We can also update the total expenses value by first iterating through each expense. So we can use the fold method to get the sum of all the amount fields values. Finally, we then update the onError callback and update the state to show a failed expense list status. Secondly, we create the underscore on expense deleted callback. Inside this, we simply call the delete expense method from the repository. We also supply the expense ID using the event. Thirdly, we create the underscore on expense category filter changed callback. Inside it, we simply emit an updated state with the new filter we have just selected. For our homepage, we have implemented a simple UI that shows the total expenses made by the user. Beneath that, we have a list of the categories, and then the rest of the screen contains the list of all the expenses stored in the local storage. In the code, we have refactored each section to make for a more readable code base. Starting with the total expenses widget, all we have to do is to listen for the changes in the state of the expense list block. Next, we will need to format the value gotten. Therefore, we create a variable called total expenses to which we return a formatted value using a method we have created in the utils folder called format underscore total underscore expenses.dat, which looks like this. Finally, back in the total expenses widget, we can then replace the hard-coded amount with the formatted total expenses value gotten from the expense list block state. For the expenses widget, which contains our list, we start by wrapping the list view widget with a block builder. For this, we can then use the IntelliSense context menu gotten from the block extension in VS Code. Inside the builder callback, we first check if the status of the block state is loading. If it is, we return the loading widget. Next, we can then get the expenses list from the state by calling the state.expenses. Using this expense list variable, we can then confirm if the state status is successful and if the expense list is empty. If the list is empty, we return an empty list widget. Finally, we can use the expenses variable in the list view item count and also as the property for the expense style widget using the index from the list view. Before we can view anything, we must not forget to add the block provider for the expense list block, which will be above the homepage. The best place we can add this block provider for our app is just above the material app widget. Therefore, as an immediate child of the repository provider.value widget, we wrap the material app widget with a block provider. For the create callback, we simply return the expense list block. We then supply the expense repository value to it, as we can see here. Now, if we do a restart of our application, we should be able to see the expense we created earlier. We are currently not seeing anything after restarting. Can you guess why? Well, we have not initialized or triggered the event in the expense list block that will get the list of expenses from the local storage. To do this, we simply come to the block provider for the expense list block. Just outside the create callback, we call or trigger the expense list subscription requested event using the add method like this. After a hot restart, we can see that the list has been updated with one expense from the local storage, and our total expenses widget has also been updated.
To implement the update function for an event, we need to make changes to the expense form block. Start by adding a new nullable property initial expense to the expense form state class. add the initial expense argument to the copywith method and set the property like this. Don't forget to add it to the props list. Now, in the expense form block class, we first add an initial expense property to the constructor. We then set the initial state for the initial expense property like this. Using the initial expense property we just created, we initialize the other properties of the expense form state so that when an item is tapped to be updated, the fields in the expense form state will be initialized with the values in the currently selected expense. Finally, in the underscore unsubmitted callback for the expense submitted event, we will make changes to the expense variable here. Therefore, we update the initial expense using the copywith method, setting each value to the newly updated state values. But if the initial expense is null, we create a new expense as we did before. Now, we can add the initial values of each field, starting with the title field widget. Set the initial value property for the text form field to the title from the initial expense. For the amount field widget, we do the same thing, but this time we add the toString extension. In the date field widget, we update the formatted date variable by first checking if the initial expense is null. If it is, we format the date from the state. Else, we format the date from the initial expense property like this. Next, in the show add expense sheet extension we created earlier, we first add a nullable expense as an argument. Using this argument, we set it as the initial expense property in the expense form block when it is created or initialized. Finally, in the expense style widget, we scroll to the list style widget in it. Inside the list style widget, we set the untapped property to call the show add expense sheet method, and then we supply the expense from the widget to it. With that saved, if we tap on an item in the list, we see it opens up the add expense bottom sheet. We can also see that the different fields have been initialized with the values from the initial expense. Once we are done making our preferred changes to the currently open expense, we can submit it to see that our changes have been applied to that particular expense in the list.
Let's implement the delete event from the expense list block. We have already refactored our expense style widget to this file. All we have to do is to wrap the top list style widget with a dismissible widget, as we have done. We provide the key property as value key with the expense.id value. We set the direction property to dismiss direction.end to start. We can add some background decorations, for which we have used a simple container with the following properties supplied. And finally, in the undismissed callback, we simply add the expense list expense deleted using the context read method, and then we supply the current expense to it. With that saved, if we swipe to the left on any of the expense style widgets, we can see that we have successfully deleted an expense and it is no longer in the list. We have already created the category enum for each expense we create. We can therefore use this to filter our expenses using the block library. So simply update the extension and add a method that returns a value of bool called apply. This method will compare the currently selected category to the category in the expense. If they match, then it will return a true value, else it will return false. So we simply return a switch for the current category using the this keyword. We then provide all the possible elements for the category enum as we have done here. After that, we also provide an apply all method which returns an iterable of expense. It will also take an iterable expense as an argument, for which we will then use the where method and supply the bool apply value we have just created. Next, inside the expense list state, we have already created a field for the category. Therefore, using a getter, we call the filter field from the state and call the apply all extension, and then we can pass in the expenses list field from the state as the argument. We can then update our expenses widget. Instead of getting the expenses list using the state.expenses, we just replace it with the state.filtered expenses. Lastly, our category choice chips at the top of our homepage are not functional yet. To fix that, we go to the refactored expense filter widget. Inside it, we simply use the context.select method, which listens to changes in a single value of the block state rather than the whole state. We return the block.state.filter as the active filter. In the choice strip widget, we update the selected property and set it to compare the active filter variable we have just created to the currently indexed category from the list. And finally, for the unselected callback, we can then add the expense list category filter changed event and supply the currently indexed category. After a hot restart, we can see that I have added some extra expenses to the list. If we then tap on a particular category, we can see that it returns a filtered list containing only the expenses belonging to that category. With that, we have created a simple expense tracking app that creates an expense using a simple form, which is then added to a list automatically in the app. And we can also update any of the saved expenses by tapping on any expense item in the list and changing what we want in the form. Or we can delete it by swiping any of the expense list items to the left. All this using the Bloc library. If you found this video helpful, please like, share, subscribe, and don't forget to tap on the notification bell so you can be notified of our new content.